Okay, I lied. I said in the last one I was only going to do one more. I'm going to do two more problems, two more examples. Okay, so the first one I think is pretty easy. I don't think it's too hard, but this is a typical question that sometimes gets asked. And it says, are 49 to 7 and 70 to 10 equivalent ratios? How would you go about proving that yes they are or no they are not? Well, remember the cross product principle. That's what's going to make this check out for us, okay? Or not check out, we'll see. So first thing to do is to write the ratios that they give us, okay? The two ratios, the two complete ratios. So the first one is 49 over 10, over 7, right? 49 to 7. And the next one that is supposed to be equivalent to is 70 to 10. Okay? Now, what does that cross product principle say? It says that if I multiply this way, the answer should be the same as if I was to multiply this way. So let's try it. 7 times 70 is 490. Okay, and that was multiplying this way. Now that should be equal to the other diagonal multiplication. If it doesn't, if it's not equal, then they're not equivalent ratios, okay? But as you can see in this one, they are. So yeah, these two are equivalent ratios, okay? So that's where the cross product principle helps out, right? We can prove that yes or prove that no, they are or they are not equivalent ratios, okay? So like I said, that one wasn't really too hard. But I'm going to show you one that I think is probably the hardest one we've seen today, and at least in this video. Okay, so I'll read it. In fact, maybe you think, I can do these already. I got this. I got this. Maybe you want to pause it and give it a shot yourself and see how you do. Okay. So if not, though, I'm going to read it. It says, Luke earns $14.50 an hour. Luke works 40 hours a week. Before deductions, his pay was $290. How many hours did he work? Okay, so I guess the first thing to do here is to determine whether or not it is a proportion problem. How do we do that? Remember I said there should be, in a proportion problem, there should be 3 values, and 2 of them should have the same unit of measure, right? How many values do you see here in this problem? Well, it looks like I have 3, right? I have 1450, I have 40, and I have 290. Looks pretty good to me. Do 2 of them have the same unit? Well, this has a dollar sign and that has a dollar sign, so it looks like yeah, right? This is a tricky problem. Believe it or not, there's actually another value. This problem has 4 numbers. Do you see the 4 numbers? No, maybe not. Or maybe I can ask you, do you see the first complete ratio? In a proportion problem, there's always going to be at least one complete ratio. Okay, so can you see it? Can you? It's this one. It's $14.50 an hour. How many hours? 1. So this is what's called a unit rate. It's a special type of ratio that has a 1 in the denominator. And as you can see, it kind of hides. It's easy to skip over that an hour and not understand or realize that there's actually a number 1 right there. So I'm going to write this ratio down first, okay? And I need to maintain the same pattern in the second ratio, okay? Dollars on top, number of hours on the bottom. Okay. So what's the next piece of information that I need to put? Now remember, I'm only missing one more. I told you guys that proportion problems are always going to give us 3 numbers, and we have to find the 4th one. So really all we're missing is one more, either a dollar or an hour amount. We'll see what they're asking for. So I think it's interesting that this information, Luke works 40 hours a week, is actually information we don't need. That's extra information. And I always have students ask me, so why do they put the extra information in there if we don't need it? To see if you understand that you don't need it. That's why. So actually, Luke got $290 in his paycheck, and they want to know how many hours he's working for that money. That's the ratio that we have. So we know that he got paid $290, and they're asking us about how many hours is that worth. Okay, so that's the proportion problem, and I think it's tricky all because of that unit rate. And just to repeat, and I know I repeat myself a lot, but proportions for my students, proportions are difficult not because of the concept of cross product principle. No, it has more to do with the fact that ratios have so many ways of being expressed. At least, well, 3 ways at least, right? Okay, so let's go ahead and finish the problem. So we would multiply diagonally, cross product principle, right? So 1 times 290 is 290, divided by 1450, the other number that we haven't used, and that will give us 20. So it would seem that Mr. Luke here is a part-time worker, or at least this is a part of the whole check, okay, half a check, because we know that he actually works 40 hours a week. Okay, so that's it. I think I've covered most of the different kinds of examples that proportions look like, or proportion problems will present themselves to you. So